Hello everyone, my name is Robert Garza, and today we're going to be taking a look at Petya ransomware. So this ransomware was similar to WannaCry in the way that it was distributed, but we don't see the same weaknesses in the code that was present in WannaCry, and we also do not see any kill switches. So in the past, this ransomware unfortunately was quite successful. It was widespread. Um, It took down large infrastructures, businesses, hospitals, etc. So today we're going to see what kind of malicious indicators we can pull out from a process perspective. We're going to do some behavioral analysis and take a look at some of the traffic. And we're also going to take a look at some of the strings in memory. And finally, we're going to throw this in a disassembler and see what kind of indicators we can pull out from a disassembly perspective. Let me scroll down here, the file details. You'll see that this malware sample is actually a DLL, so I have to invoke this malware sample slightly different than your typical executable, and I'll show you how that works in just a second when we get started. Alright, so just a quick overview of some of the tools we're going to be using today. So we're going to be using my Windows 7 64-bit VM. We're also going to be using my Remnux distro. We're going to throw this in the disassembler, IDA Pro. And in the background, we're going to be running the burp suite and fake DNS because this malware sample, it will try and call out to a C2 server. So obviously we need to elicit a response. So we'll go ahead and run those tools in the background. And we're going to be using Process Monitor. I got that running. And Process Hacker. And I think that's it. So just a quick video disclaimer before we get started here. I'm somewhat new to producing videos, and this is all going to be done in one shot, no video editing, anything like that. So please excuse any mistakes or errors. All right, so with that, let's go ahead and get started. So in case you're not familiar with these tools, we're going to be using Process Hacker to look at the strings in memory. And then I have Process Monitor here. And we have a filter set to show where the operation is process create. So obviously we'll be able to see any processes that were spawned and the command line invocation, and we'll be able to see how everything that was executed. I'm going to go ahead and get these out of the way for now. All right, so I do have an admin prompt running. So in order to successfully execute this malware sample, you do need to run it as admin. If not, if you just run this as a regular user, the malware will try and propagate around the local network and possibly the external network as well. And we do not want that. I just need to do one thing real quick. I am collecting logs from this machine to my Splunk instance. So I need to turn off the universal forwarder. Otherwise, we're going to get a bunch of noise, a bunch of logs that we don't need to collect right now. So I'll go ahead and stop that service. All right. Let's get back out of here. Oops. Okay, clear that. All right, so as you can see, I do have the malware sample on my desktop. So we'll go ahead and switch to that directory. Then we'll need to give it the name of the DLL, which is Petya. And then we also need to call the order value or entry point. And in this case, it's going to be 1. So let's go ahead and do that. .32 petya.dll number 1. All right, so just executed. Let's have a look at Process Hacker, and we see down here a new process will spawned. Um, let's close this for now. We'll come back to that in a second. Let's have a look at Process Monitor. Let's make this bigger. That's not important. All right, so looking at the detail column, we see one of the first things that was done was a scheduled task was created to shut down my machine at this time. And then we see some redundant processes being created as a failsafe. So we'll go ahead and let this run in the background, and we'll come back to it, see if there's anything else new. So for now, close this down. So let's take a look at Process Hacker and look at the memory strings. See if we can find any malicious indicators in there. Let's go ahead and make this bigger. That's better. All right, so scrolling down here in the memory strings, so we see that a scheduled task again. One thing I wanted to mention, I forgot to mention it earlier, is that the so we did execute the malware, and if you notice, my machine is still intact. It's not encrypted or anything. So that's what this task schedule is for. So the encryption process doesn't start until the machine restarts. And if you wanted to, we can have a look at that task right in the schedule itself. So let's have a look at that, and we should see it right in there. And it's the only scheduled task. So we see has this odd looking name to it, and well, we can just expand this. You see that name, and then the time that the machine will restart. All right, so let's continue scrolling down here, see what else we see. So scrolling down, so we should see, where is it? There we go. So over here we see the message that we're going to see in a few minutes here. As soon as I restart the machine and it gets encrypted, this is the message that will be displayed. And right above that, we see the Bitcoin address, as well as the address in order to send over the key information. Then continue scrolling down. So here's an interesting string. It's CL security. So this suggests that the malware is actually going to wipe all of the security logs, the system logs, setup logs, application logs, etc. is all going to be wiped by the malware. So then we see WMIC, and then underneath that /node and some variables after that. That would suggest WMIC across the network. So if you see something with /node and say like a list of IP addresses, this would probably indicate how the malware is trying to spread across the network. All right, so speaking of IP addresses, let's go ahead and filter um, for network traffic and see if we can find any other malicious indicators in there. So yeah, it looks like wait a second. Let me redo this. Let's do 192. Okay, there we go. So right here we can see that the malware is trying to connect to admin $shares, and that's about it. We're just going to see a bunch of that. So actually, this reminds me, because we're not seeing any other malicious traffic. So I mistaken this malware sample, because I do have other variants of Petya malware samples. So this one right here, we're not actually going to find any other malicious traffic because this particular variant is using the double pulsar and eternal blue exploit, which already has the backdoor built into the binary. All right, so I think that's about all we're going to find here in the memory string. So we can exit out of this. That's good. Nothing new in there. So I think we're going to go ahead and switch over to Remnux and throw this or disassemble the binary. So actually, before we go ahead and switch over to my Remnux box and disassemble the binary, let's go ahead and start the encryption process, because that does take some time, and I wanted to show you how that looks. So we can go ahead and forget about the task schedule because it's not going to happen for a while. Let's just go ahead and force a restart, and we'll see that encryption process start. There we go. So here, let me exit out of that. So it looks like it started. Obviously, this is somewhat of a misleading message. It's actually encrypting the entire file system. All right, so while that's running, let's go ahead and throw Petya and Ida, and we'll just have a poke around for a few minutes. We're already running on 15 minutes here, so we'll just have a poke around and see if we see anything of interest. Actually, let's go ahead and switch over. It should be just about done. Yep. 98%. All right, there we have it. This file system. Oops, your important files are encrypted. So you can go ahead and try and input a key, and we're just going to keep on getting this message. And one other important thing to note before I revert my machine to a clean state, my files are indeed encrypted. I'm not sure how familiar you are with Petya, but there are some other variants out there that were poorly coded, And you could actually live boot into the machine and recover your files because the malware actually only encrypted the master boot record, but not in this case. Unfortunately, this variant right here, it does encrypt the entire file system. So I think we're done with that. So let's go ahead and poke around in IDA real quick and see what we can find. So one of the first things I like to look at in IDA is the names window. So these are actually the names of the imports of the API calls that the malware uses. So let's have a scroll. So earlier we did see some network connections. So one of the things I'm interested in is anything with add connection. And here we go. So we see this right here, WNet add connection to. So we'll go ahead and double click that. And then right here we see a reference to the API call. And yeah, we can go ahead and double click on that. And then I think we want go with this one. Nope, this is the wrong one. Let's go back to the names window. This should be it. All right, so yeah, so went ahead and double click on that. You hit X, and here we can see where that call, the API call, is being cross-referenced in the code. So we can go ahead and go to that entry. So if you're using a debugger like Ali Debug or even X64, just before this call right here, you'd want to set your breakpoints in those memory locations, and you would be able to monitor those network connections as they go through step by step. And then right here, just before that call, we can see a call to that process, the username, password, and resource that's actually being passed to that function as arguments in the whole stack. So essentially, you would be able to see the IP addresses and passwords that were being passed to actually make those connections. But we're not going to get into debugging in this video. It's quite time consuming. But I do cover a little bit of debugging in some of my other malware analysis videos. So be sure to check that out. But one thing I do want to check out before I wrap this up, let's go ahead and scroll over there, is the R data. There we go. So the R data section is always quite interesting because we get to see some of the text that is actually being used by the malware and called at runtime. So we can have a scroll down here and start poking around. Let's start right here. So we can see some of the messages that we saw earlier, the encryption message. We see that Bitcoin address. We see a reference to Bitcoin wallet ID, that email address to send over the key information. So scrolling down here. So right here, we see this huge config of the file types that are being targeted and pulled from the actual binary. So we see a lot of the common file types, docx, doc, VBS, PowerPoint, RAR, zip. So this is actually similar to what we saw earlier in the memory strings and process hacker as well. Let's continue scrolling down. So over here, it looks like this is just a bunch of the encoded data in IDA. So we can skip past this. There's one other thing I wanted to review. Our data. I think we passed it up. Here we go. Kernel, cmd. All right, so here's some of the stuff that we saw earlier in the memory strings and process hacker. So here's some references. The run DLL, the WMIC, the node. Those admin $ shares that were being accessed as well by the malware. And I think that's about it I wanted to cover in this malware analysis video. We're already going on 22 minutes. And I almost forgot. There's one other cool tool that I want to show you just real quick. PE string. It's a nifty little tool that's prepackaged in Remnux. So if you run that on your binary, you can see some of the strings. You can pull some of the strings out of it. So let me open up a terminal. What happened? It's PE string. Yeah, no space. All right, so that just ran. So we can have a look at some of the strings in the binary. So this is similar to what we just went through in IDA and also in Process Hacker. We'll see a lot of the same things, but in order to make this easy to read, let's go ahead and pipe this out to a text file. We'll call it petya1.txt. So we'll just keep scrolling down here until we see anything of interest, what we saw earlier. Here we go. There's a big blob of data. So this is exactly what we saw earlier. Well, we saw some of this in IDA Pro as well, and Process Hacker. So we see the email address, that Bitcoin wallet, the address, and of course that message, the encryption message. And that's about it. As always, I'd like to wrap this up with lessons learned, just in case you were impacted by this in the past, last year when this was circulating. So first and foremost is phishing awareness. Phishing awareness is key. you always want to try and be proactive, be on the proactive side of security and not so much reactive all the time. Or ideally, in the long run of your cybersecurity program, you want to go from reactive to predictive security. And that starts with a great threat hunting team. That's actually one of my long-term goals, is to become a great threat hunter one day. Sounds like a lot of fun. Anyhow, second, backups. Backup. Because of course, in this case, there really is nothing you can do if you were compromised. You definitely, you always, excuse me, you definitely do not want to pay the ransom. So you really have no choice but to just restore from backup. And hopefully you weren't impacted too hard. But in the case you were, you may have to implement your disaster recovery process. So I think that's about it. Yep. Just check one thing. All right, so that's it. I hope you got some good value out of this malware analysis video. Thanks for watching. Be sure to check out my other videos, and we'll see you soon. Thanks.